I'm glad to see you were able to find this video. I'd also be glad to hear from you. Let me know what you want to see or what you're having trouble with so that I can make content that's useful and meaningful to you. With that said, let's jump right in, shall we? So our previous video was the lecture portion of the Exponents module for the Orders of Operations video series that we're doing here. And so what we did is we went in and we looked at how do you handle an exponent, whether it's positive or negative, and how do you handle an exponent whenever there's actually more operations associated with that exponent. So we went over a few different examples and we talked out how you actually go about that. So if you're having any problems, I suggest rewatching that video or let me know in the comment section below so we can go ahead and give you some more examples on how to actually go about solving exponents. But today, we're actually going to take up the practice questions that were at the end of the lecture portion of the video. But before we start that, let's just start at a quick little refresher. You always want to make sure you expand out your exponents, and really what an exponent is saying is you're taking your base number and you're multiplying it by itself, however many the exponent is. So if you have a base of, let's say, 2 to the power of 3, you're multiplying 2, because that's the base number, by itself 3 times. So what you're actually doing is 2 times 2 times 2. Now, sometimes you're going to have a negative exponent. If you have a negative exponent, the easiest way to solve it is to flip it to a reciprocal. So you want to make it positive. And so what you're going to do is you're going to divide it by 1. So you're going to have the 1 on top, and you're dividing it by the positive version of your exponent. So you're keeping the base the same, and you're keeping the exponent the same. The only difference is that you're making it positive. So if we had an example of 3 to the power of negative 2, what we're going to do is we're going to flip it. So it'll be 1 divided by 3 to the power of 2. So we've now made it positive, and now we can go ahead and solve 3 times itself twice, because there are 2 exponents. The exponent is 2, so it'll be 3 times 3. And then once we solve that, because 3 times 3 is 9, we can go 1 divided by 9. So the tricky part of exponents is the negative exponent. So keep that in mind. Remember, you want to flip to the reciprocal before you start expanding. Also, there are times when you're going to have operations that are associated with your exponent. There could be brackets, it could be multiplication, it could be addition, subtraction, it could be more exponents within an exponent. Regardless of what that is, you're just going to start over within the orders of operations. You're going to go back to your acronym of BEDMAS and check to see, are there any brackets? Are there any exponents? Is there any division, multiplication, addition, subtraction? Work your way through it as you go. And every time you see a new level, like you find a bracket or you have an exponent on top of an exponent, you always start back over and say, are there any brackets? Are there any exponents? Let's go ahead and look at some examples, because just lecturing about it can be kind of confusing, but seeing some practical expressions and some equations might actually make it a little more tangible. So here were the example questions that I left you on Tuesday, and hopefully you had a chance to look at them. But let's go ahead and start solving them. So here we have 2 to the power of 2. So our base number is 2, and our exponent number is 2. So what we're saying is 2 times itself twice. So you're going to have 2 times 2. There's 2 2's, and we're multiplying them together. 2 times 2 is equal to 4. So there's no further operations. Our final answer is 4. So it was straightforward. Let's go ahead and try the next one. So we have 3 to the power of negative 3. So our exponent is negative in this case. So what we want to do is we want to go ahead and flip the whole equation, so that way it is positive. So we're going to go ahead and say 1 over 3 to the power of 3. So now our exponent is now positive. Now we're going to go ahead and break out our exponent. What we're saying is 3 times itself 3 times. And we're going to drop the left side, the 1 divide, and we're just going to expand out our 3 times 3 times 3. Now that we have brackets, because whenever we expand, we want to make sure we put it in brackets to make sure that we don't forget, and we do those things first. 3 times 3 is equal to 9, and we drop the rest of the equation. 9 times 3 is equal to 27, and we can remove the brackets because now the brackets aren't doing anything for us. They would just be there to hold the 27. Now we can go ahead and say, let's do the division part. 1 divided by 27 is equal to 0.4. So our final answer is 0.4. So here we have another negative exponent. So we want to go ahead and flip the whole base and exponent to be over 1. So that way we get the reciprocal of it so we can make it positive. Make the exponent positive. So we have 1 over 4 to the power of 2. So we want to go ahead and expand out our exponent. So what we're saying is 4 times 4, because there's 2 4s, because the exponent was 2, and we're dropping the rest of the equation. Now 4 times 4 is equal to 16, and again we drop the rest of the equation. Now we can go ahead and say 1 divided by 16 is equal to 0.06. That gives us a final answer of 0.06. So D, our base number is negative, but our exponent is positive. This means we do not have to flip this. We do not need the reciprocal. What we're doing is we're making sure we capture that negative sign that's associated with our base number, and we're multiplying that by itself twice in this case. So it'll be -6 times -6. Now we have a negative and a negative number. Because the signs are both the same, we can go ahead and flip that to a positive. A negative and a negative will give you a positive. And then 6 times 6 is equal to 36. There's no further operations required, so our final answer is 36. So remember, we're only needing the reciprocal if the exponent is negative. If the base is negative, we leave it alone. But we have to remember to keep that negative sign with our base. F, or E. I'm getting ahead of myself. E, 4 to the power of 3. So our base number is 4, and our exponent is 3. So now we're going to have 4 times 4 times 4. There's going to be 3 4s, and we're multiplying them all together. Go ahead and solve the first one first. 4 times 4 is equal to 16, and we drop the rest of the equation. 16 times 4 is equal to 64. There's no further operation, so our final answer is 64. Now F, we have a negative number, but it's the base number that's negative, so we don't have to flip it. We do not need the reciprocal. What we're doing is we're taking the -2 and multiplying it by itself twice. So -2 times -2. Remember, you have to bring the negative sign with you. So a negative times a negative is equal to a positive. 2 times 2 is 4, so our final answer is +4. So G, if we look at this one, it might look a little bit more difficult because on our exponent, we actually have an operation that we have to do before we can go ahead and expand out our exponent. So 3 plus 1 is 4. So we can go ahead and simplify that. Now we have -4 to the power of 4. So all we're saying is multiplying -4, we want to remember to keep the negative sign associated with our base, and multiplying it by itself 4 times. So we have -4 times -4 times -4 times -4. And again, we're only going to solve the first operation first, so we're just going to look at the first 2 4s. -4 times -4. Well, a negative and a negative will give us a positive, and 4 times 4 is 16. And we drop the rest of the equation. Now we have a positive 16 times a -4. Well, a negative and a positive will give you a negative, and 16 times 4 is equal to 64. So now we have a -64, and we drop the rest of the equation. -64 times -4, we have a negative times a negative, so that's going to be a positive, and 64 times 4 is 256. There's no further operation, so our final answer is 256. I think by this point we can see that the bigger your exponent is, the bigger your final answer is going to be, unless it's a negative. If it's a negative, it's going to make it smaller, right? Either way, we're getting into longer numbers, depending on how big the exponent is. So H is -3 to the exponent 3. So the exponent is positive, it's the base that's negative, so we want to make sure we keep the negative sign with the 3, and we want to multiply that by itself 3 times. So there's going to be 3 -3s, and we're multiplying them together. We go ahead and solve the first one first. -3 times -3, we have a negative and a negative, that will give us a positive, and 3 times 3 is 9, so we have a +9, and we drop the rest of the equation. 9 times negative 3, so we have a positive times a negative, that's going to give us a negative, and then 9 times 3 is equal to 27, so our final answer is negative 27. I, we have negative 2 to the power of 4. The base is negative, not the exponent, so again, no reciprocal, we don't need to flip it. We just need to remember to bring that negative with the 2. So negative 2 times itself 4 times. So there's going to be 4 negative 2's that we'll have to multiply together. We're going to solve the first set first, because you only want to do one operation per line. Negative 2 times negative 2. Well, a negative and a negative will give you a positive, and 2 times 2 is 4, and we drop the rest of the equation. Now we have a positive 4 times a negative 2. So a positive times a negative will give you a negative, and 4 times 2 is equal to 8, so we have a negative 8. And again, drop the rest of the equation. Now we have negative 8 times negative 2. Negative 8 times negative 2, a negative and a negative will give you a positive, and 8 times 2 is equal to 16, so our final answer is a positive 16. J. So this one's a little bit interesting because the base is negative and so is the exponent. Now, because the exponent is negative, we need to flip and get the reciprocal. So what we're going to say is it's 1 divided by negative 2 to the power of 2. The only sign that is changing when we get the reciprocal is the exponent. The exponent becomes positive. The base will keep whatever sign it had before you flipped it. Okay? So now we can go ahead and we can start we'll expand out the actual exponent with the base. So negative 2 to the power of 2 means we're taking negative 2 times negative 2. So we'll go ahead and write that out. Now, because it's a negative and a negative, that will give you a positive, and 2 times 2 is 4. So this gives us 1 over 4. If we divide 1 divided by 4 is equal to 0.25. And there's no further operations required, so our final answer is 0.25. So the thing to remember when you have to get the reciprocal, it's when the exponent is negative, and when you flip to get the reciprocal, only the exponent becomes positive. We are not changing the value of, or not the value rather, but the sign, whether it's positive or negative, to the base. It will remain whatever it was before you did the reciprocal. It's only the exponent that changes. K, we have 9 to the power of 3. So what we're saying is multiplying the base 9 by itself 3 times. So we're going to have 9 times 9 times 9. So we go ahead and solve the first operation first. 9 times 9 is equal to 81. And we drop the rest of the equation. 81 times 9 is 729. There's no further operations required, so our final answer is 729. L, negative 7 to the power of 2. Again, it's the base that's negative, so we do not have to flip it. We can go ahead and just solve it. So what we're saying is negative 7 times itself. So we have negative 7 times negative 7. A negative times a negative will produce a positive, and 7 times 7 is equal to 49. So our final answer is positive 49. M, we have 2 to the power of negative 2. So we have a negative exponent, so we want to go ahead and flip it to get the reciprocal. So we're going to say 1 over 2 to the power of 2. And the exponent is now positive. Again, we're not changing the state of the base. The base was positive before, it's going to be positive after. So let's go ahead and expand out our exponent. We have 2 times 2, and we can go ahead and solve that. So 2 times 2 is 4, because they're both positive numbers. We don't have to worry about that, and 2 times 2 is 4. Now we have 1 divided by 4. 1 divided by 4 is equal to 0.25. There's no further operations required, so our final answer is 0.25. N. Okay, so let's look at n. We can see we do have an exponent, and then attached to our exponent there are brackets. So we want to go ahead and solve the brackets first. Inside of our brackets there are no child brackets, so we can go ahead and solve the minus 2 plus 1. Minus 2 plus 1 is equal to minus 1. Now we have a negative 3 directly beside an opening bracket. This means we need to expand out our bracket, so we're going to take negative 3 times negative 1. Negative 3 times a negative 1, you have two negatives. So a negative times a negative will give you a positive. And 3 times 1 is equal to 3. So we actually have an exponent of positive 3. So now that our exponent's been cleaned up, we can go ahead and just solve the exponent. We have a base of negative 3 and an exponent of positive 3. So what we're saying is we're multiplying negative 3 by itself 3 times. So we're going to have negative 3, negative 3, negative 3. We're going to go ahead and solve the first operation first. Negative 3 times negative 3. A negative and a negative will give you a positive, and 3 times 3 is 9. We drop the rest of the equation down. Now we have a positive 9 times a negative 3. So a negative times a positive will give you a negative, and 9 times 3 is 27. There's no further operations required, so our final answer is negative 27. So always remember, you want to solve the brackets first, and you always start with the innermost bracket. So there was no parent bracket out here at the root level. All we had was the exponent. And when we went to go solve the exponent, there was a bracket, so we needed to solve that bracket. If there had been another bracket within it, you always do that one first, right? So always keep looking. Are there any brackets? Are there any brackets? Always make sure you do your brackets first. Oh, we have 4 to the power of negative 3. We do have a negative number, or a negative exponent, so we have to go ahead and get the reciprocal. And that means we have 1 over 4 to the exponent 3. Only the exponent gets flipped, so the 3 is now positive. We're leaving the 4. We're not changing its sign, and we can go ahead and expand out the exponents. What we're saying is 4 times 4 times 4. We can go ahead and solve the first one first. 4 times 4 is 16, and then drop the rest of the equation. 16 times 4 is equal to 64, and again we drop the rest of the equation. 1 divided by 64 is 0.02, and so our final answer is 0.02. 12 to the power of 2. So what we're saying is our base number is 12, and we're going to multiply it by itself twice. So there's going to be 12 times 12. They're all positive numbers, so we don't have to worry about that. 12 times 12 is 144. There's no further operation, so we can go ahead and say that the final answer is 144. We have 9 to the power of 2. Again, they're all positive numbers, so we don't have to worry about our signs. What we're saying is 9 times itself. So we're going to have two 9s and we're multiplying them together. So 9 times 9 is equal to 81. And there's no further operations required, so we can go ahead and say our final answer is 81. R, we have 2 to the exponent negative 5. Now, our exponent is negative, so we have to go ahead and get the reciprocal. So we're going to say it's 1 over 2 to the power of 5. Again, only the exponent is having its sign changed. Everything else is the same. We can go ahead and expand out our exponent. So what we're having is 5 2's, and we're multiplying them all together. We're going to go ahead and solve the first one first. So we're going to go 2 times 2 is equal to 4, and drop the rest of the equation. Now we can go ahead and say 4 times 2 is equal to 8, and again, drop the rest of the equation. 8 times 2 is equal to 16, and again, we drop the rest of the equation. 16 times 2 is 32, and we drop the rest of the equation. 1 divided by 32 is equal to 0.03, and there's no further operations required, so we can go ahead and say our final answer is 0.03. So as the exponent gets bigger, there's more that has to be done when solving it by hand. If you're using a calculator, you could just punch it in and you'll get it in one step, but we're trying to learn the fundamentals of how things work, and so if the exponent is bigger, it's only giving you more steps, right? Because we're only solving one operation at a time, so it's not making it any more difficult, it's just making it longer. Now we have negative 12 to the exponent 2. The base is what's negative, so we don't have to flip it. We do not need the reciprocal. What we're saying is negative 12 times negative 12. The two signs are both negative, so we can go ahead and convert that to a positive, and 12 times 12 is 144. There's no further operations required, so our final answer is 144. T, we have a negative base, and then we have an addition associated with our exponent. So we're going to go ahead and clean up our exponent first. We're going to say 2 plus 2 is equal to 4. So now we have a negative 5 to the power of 4. The base is negative, so all we have to do is remember to keep the negative sign with the base, so that way whenever we expand it, it'll be -5 times -5 times -5 times -5. It's only when the exponent is negative do we need the reciprocal. But we do have to remember to keep the negative sign with the base. So now we can go ahead and solve this one. We'll do the first one first. -5 times -5. That's a negative times a negative, so we'll get a positive 25. Now we're going to go ahead and say positive 25 times -5. Well, a positive times a negative will give you a negative, and 25 times 5 will give you 125. So now we have 125 times 5. Negative 125 times -5. Remember, keep track of your signs. A negative times a negative will give you a positive, and then 125 times 5 will give you 625. There's no further operations required, so our final answer is 625. So, as a summary, exponents are the second step in the order of operations. The first thing you want to do is look to see, are there any brackets? Once you've solved all the brackets that you can, you go ahead and start looking at your exponents. What an exponent means is to take the base and multiply it by the frequency, by itself, by the frequency of the exponent. So if it's 2 to the power of 3, you're multiplying 2 times itself 3 times. It'll be 2 times 2 times 2. There will be 3 base numbers and they'll be multiplied together. If the base number is negative, you have to bring the negative sign with it when you're multiplying it. So if it was -2 to the power of 3, it's -2 times -2 times -2. Now if the exponent is negative, you need to make it positive. This means you need to get the reciprocal. So we're going to take the base and the exponent and flip it over 1. So it's going to be 1 divided by the base, and the exponent becomes positive. The base will stay whatever sign it had been before you flipped it. It's just the exponent that's changing. Also remember, if you have any kind of operations associated with your exponent, you solve those first. You always want to make sure your line is as clean as possible. And so if you see an exponent and there's something attached to it, you start back over, are there any brackets? Are there any exponents attached to any of the parts within my exponent? And work your way through the orders of operations that way. Keep track of your signs. I've done it at least once in this video where I was reading through the example and I misspoke on whether or not something was negative or positive. But that's the kind of things that are going to get you, and they're going to really be frustrating because as you go through and you're trying to find where your errors were, where did you come off track, signs are really hard to see because the math, like it's not like it's a multiplication or an addition or a subtraction or division thing that was wrong. It was just that you converted the sign either to a positive or a negative when it should have been the other way. So it's a little bit trickier to find, so really do keep an eye on your signs. It's easy to make a mistake with. So our next video will be on Tuesday, and it will be the lecture part of the division and multiplication module within our orders of operations video series. And so we're sticking with BEDMAS. We've done the brackets, we've done exponents. Division and multiplication is the last module section within the orders of operations that we'll have to go through, and then we'll do a summary of everything together, because we have really, at this point, we've really focused on each individual operation step to make sure we understood how that works. So we'll take a look at how division and multiplication play within the orders of operation. You know I love to hear from you, so if you have any questions or any future topic ideas that you would like to see, let me know. Reach out to me in whatever channel suits you best, and I look forward to seeing you at the next video.